So today's program is part of the National Library's S.U.R.E initiative, which promotes the importance of being discerning when handling information. Please welcome Professor Efim Zelmanov. Please welcome Professor Randy Schekman. Please welcome Sir Fraser Stoddart.
So we are, of course, on behalf of the National Library Board and the National Research Foundation, we'd like to thank every one of you for attending our event this evening. And so just, of course, we would like, to break the ice a little bit. So I would like to open up, this particular segment to our three distinguished guests. So gentlemen, my challenge for you in 5 minutes, you just have to introduce yourselves to the audience, tell them a little bit about what you do, and perhaps, a little known hobby that you have. So that'll be, yes. So just something about yourself, maybe. All right, so maybe I would like to start off with Professor Zelmanov. Yes.
I teach at the University of California, San Diego, try to solve problems in algebra. As hobbies, travel, read books, meet friends. Isn't it enough?
Yes. And something else very interesting later that I can share with everyone in my interaction with Professor Zelmanov earlier in the evening. So moving on to you, Professor Schekman.
I also teach at the University of California, but in Berkeley. And I've been there since 1976, so a very long time. I'm a cell biologist who uses biochemical tools to try to understand how protein molecules that are made inside of the cell are shipped outside of the cell by a process called secretion or export. So most of the cells in our body make all of the protein molecules that are necessary to catalyze the aspects of life inside the cell. There are roughly 23,000 genes in our chromosomes, and so that means there are at least 23,000 proteins. And every one of those proteins is made inside of a cell, but some of them, actually 30% of them, have to work outside of a cell. Molecules like insulin, you make that in your pancreas inside of a specialized cell called the beta cell, and then it has to be encapsulated inside of the cell and then exported outside of the cell. And so this was understood at the level of the microscope in the 1960s and 70s, and when I started my work at UC Berkeley, I decided to work on a simple organism called yeast, Baker's yeast, that uses a process that is the same as we use in our cells. And having made that decision, we were able to discover the genes that organize this pathway and found that the genes are the same in yeast cells as they are in human cells, even in our brains. So our brains communicate by the same encapsulation mechanism, in this case where chemical neurotransmitters are packaged and then shipped outside of the cell. And that evolutionary conservation allowed the biotechnology industry to use yeast as a platform for the production of clinically relevant proteins in large quantity. And so that was an application that came from the work, although we were and continue to try to understand basic mechanisms of how this process works. Now, one of the reasons that I'm particularly interested in this evening's topic is that for some years I've been involved in organizing scientific publications. I've been an editor of scientific journals, and I've developed, as a result of that experience and as a result of the way that we evaluate scholarship when we hire faculty members or promote faculty members, I've become aware of really the distortion in the emphasis on pizzazz and the hyping of the scientific literature in order to make a big splash. And so I'm sure that some of my answers will address that issue, and that's from my exposure to publications.
All right, thank you, Professor. So Fraser?
So like many Scots, I have traveled the world. I spent my first 25 years on a mixed arable farm south of the capital of Scotland, Edinburgh, without any electricity until I was 18. I called it the University of Life. It was where I learned all about multitasking and about hard work and effort and so on. I then spent my early education at university, at Edinburgh University, before going to Canada. So already by the time I was 30, I had spent a lot of time in different places doing the same kind of thing. I didn't actually become a professor until I was 50. The British academic system, which might be familiar to many of you in Singapore, takes you as a teacher through the title of being a lecturer, and then maybe a reader, and then finally, if you stay the course, you become a professor. I moved to the United States in 1997. The main reason I moved was my wife was suffering from breast cancer and subsequently passed away in 2004. So I have to say life has not been a bowl of cherries. For a third of our married life, we both had to struggle and contend with that insidious disease. So these last 20 years, my time has been shared between two universities in the United States, on the West Coast in Los Angeles at the University of California there, and then on the last 10 years at Northwestern in the Midwest, if you like. My research has developed over 5 decades, starting out with interest in how molecules recognize each other, and then using that recognition to bring molecules together in a self-assembled manner. And the smartest move I made, thinking back, was to have a period of 3 years out of academia with Imperial Chemical Industries in the UK at their so-called ICI corporate laboratory near Liverpool. And it was there, believe it or not, that it transpired that 2 herbicides, weed killers, that they at that time marketed worldwide, became the building blocks for our molecular shuttles, and then subsequently molecular switches, and ultimately molecular machines. And so it's somewhat of a crazy story, and it's been a great joy to be part of it. It's been a nice ride. It's nice looking back on it. It had its ups and downs. And of course, I've had my run-in with fake science news and all the rest of it. I think I'll get the opportunity to talk about this, but the one point I want to get over tonight is I am sick tired of journalists saying, "What's the application?"
Yes, thank you, Sir Fraser. So on that note, gentlemen, we will be moving on to the discussion points for today. So I will be channeling the questions around the panel. So do feel free to chip in, because we like to keep the conversations going, keep the conversations fun, most importantly. So on the topic of fake science, or basically scientific fraud, the first question that I would like to ask is, what are some of your thoughts on the topic of fake science and other academic frauds in the scientific or the mathematics community? So I think I would like to start off with Professor Zelmanov, because it will be very interesting to see, in the field of mathematics, where most of us know that it's very empirical, formulae, etc. What is your personal take on this?
Well, the problem is that science, especially hard sciences, such as mathematics, physics, chemistry, biology, has enormous prestige in the society. And if they say that it has been confirmed scientifically, then people tend to believe. And that is sometimes a problem for people who believe, for those who take decisions, and it hurts prestige of sciences. So scientists have to be vigilant. In mathematics, I would not say that there is a lot or any fraud. I am not aware of it. People make mistakes. People publish unsubstantiated claims, but practically always it's a very unfortunate but honest mistake, which is a big tragedy for the author who made it. But in the area of applications of mathematics to social sciences and economics, the standards are different. Sometimes it's quite a disaster.
Oh yes, speaking of disaster, I think that is a good way to sum up my experiences with mathematics as well, in terms of my grades. But on that note, okay, yes, so what is your take on this, Professor Schekman?
Well, I wish I could say that the life sciences, and particularly biomedical sciences, are as perfect as mathematics, but regrettably, because of the application and concerns with human health, there has been a lot of misinformation that's published in the literature. Indeed, in aspects of cancer, as we heard earlier from Fraser, that there's been a lot of misinformation published. There's a tremendous pressure in particularly the most high-profile scientific journals to publish sensational stories. So much so that people are tempted to cut corners, to hype their results, to misrepresent, and even to commit fraud in order to get their papers published in these prestigious, so-called prestigious journals. Indeed, pharmaceutical companies have encountered difficulties in replicating key studies. Some years ago, the biotechnology company Amgen found that of the 50 most important scientific publications that might have led to cancer chemotherapeutic developments, they failed to replicate over 80% of the experiments in these publications. This is a statement that's been made by other pharmaceutical companies. Indeed, the lead investigator from Amgen encountered the corresponding author of one of these papers at a cancer meeting in Boston, and he asked the fellow how they had obtained these results. The lead investigator said, "Look, we tried your experiment 50 times and it never worked." And the corresponding author said, "Well, we did the experiment 6 times, it worked once, and that fit the story best, so that's what went into the paper." Now that fraud, that obviously flawed character, I regret is not so uncommon, and I attribute a lot of it, frankly, to the scientific journals that foster this exclusivity in the capture of only a very small number of papers that cause people to misbehave, to misrepresent their work. And I'm afraid I have to say that these journals, and I've taken a very strong public position on this, these journals, largely commercial journals, the decisions are made to publish in these journals by professional editors who are in the business of selling magazines. They themselves used to be scientists, but they have long since given up active scholarship, and they're now really busy trying to sell their magazine. These are journals, and let me be specific, they're journals like Nature and Science, and in the life sciences Cell, where one finds a higher than normal proportion of papers end up being retracted as a result of evidence that the data is false. There are numerous examples of this, very prominent examples that we can get into as the discussion develops.
Right, so on that note as well, I think it is indeed a very clear and present danger of scientific fraud as well. So Fraser, would you like to build on to the topic at hand?
Yes, thank you. I'm just thinking of how I can respond to the mathematics being a pretty clean situation, and biology not so clean. I think chemistry and probably physics, but certainly chemistry, let me just stay with chemistry, lie somewhere in between. And I just want to take an example based on my plenary lecture today. I spoke about the use of carbohydrates called cyclodextrins that have had wide usage in applied senses in the pharmaceutical industry and home care products, in personal care products, and so forth. And the parent sugars, which are very simply bits of starch which have been broken up into usually 6 or 7 or 8 and given the labels alpha, beta, and gamma, repetitive glucose units in a circle so that they form a kind of donut. Much research has been done over more than 100 years to so-called functionalize these rather unique, highly symmetrical molecules. And the interesting thing is you start off with the natural product that is highly symmetrical, but when you go to functionalize it, you've got to carry out this event with impunity either 6 or 7 or 8 times over. And the literature, I have to tell you, over 100 and odd years, is a complete shambles. It's a mess. And so I think this is rather unique to maybe some particular chemical compounds where there is high symmetry to begin with, and then you break the symmetry and you lose very easy methods of characterization after breaking the symmetry. Your product can be polluted with very, very many impurities, and the techniques that we use are not able to detect them unless you are very scrupulous and push these techniques to their absolute limits. And so I have seen a situation in one area of my research where I have to say to my research students over and over again, are you sure about the purity of the material that we are working with? And particularly in my mid-career, I put a big emphasis on developing techniques to make sure that we were working with the very best. So I think there are so many different instances of where things can go astray in terms of just having the absolute true situation in science is, in the particular case I'm talking about, it's all about very good technique and wanting to be in that top class of scientists that do a perfect job.
All right, thank you, Sir Fraser. So the fascinating thing is that, you know, we start to see these parallels that all of you have shared with regards to the topic of fake sciences, for example. Like the example, okay, that Professor Zelmanov, okay, raised about unsubstantiated claims, all right, and Professor Schekman shared a little bit, you know, about, for example, even the case of sensationalism of the scientific papers and journals, and for Sir Fraser, you know, the big emphasis on, of course, getting the most, in the pursuit of academic excellence, getting the right people as well. And the interesting thing is actually that even in the context of what the National Library is doing to encourage the public to be more discerning, okay, members of, you know, just being more discerning about information, the parallels are indeed very interesting. So we're going to move on to the next question, which is related, and is what do you think are some of the challenges and opportunities in this era of, you know, online falsehoods? Because even in the scientific and the mathematical fields, do you see, you know, potentials of, you know, perhaps just using this as a platform to make, on the positive side, to encourage people to pursue more academic rigor, you know, in the field as well? So I'd like to opening up to the panel about this, challenges, opportunities. You know, do you see a positive side to this, even though there is this threat?
So with the advent of online, particularly open access publication, there have been claims that the open access journals and literature are more subject to predatory publishers. Science Magazine did a study several years ago where they wrote a fake paper, a completely fake paper, and they sent it around to a bunch of open access journals, all online, and a surprising fraction of these journals accepted the fake paper, just as a test. And now, unfortunately, the conclusion that they drew from this was that the open access literature is particularly susceptible to fake science, but what they didn't do, unfortunately, was a controlled experiment where they sent the same paper to the commercial journals, not open access journals, and I think they would have found the same thing. So the problem is that as scientists, we need to be vigilant. There's still no substitute for peer review of the literature by qualified scholars, which is why I feel so strongly that scientists should really favor those journals where all the decisions are made by active scholars and not by professional editors who are in the business of selling magazines.
Right. So I guess that is the aspect of balancing, who are the credited authors that are qualified enough to review these journals? Is that right to say?
Well, that comes up. So very often I've seen in the literature, someone sends in a paper and lists a number of potential referees, reviewers, and these people are actually not real people. They're listed with email addresses that have been that have been contrived so that the paper comes back and is reviewed by the original author or by his or her friends. So as a result, a system of validation of authors and credible scholars has developed called ORCID, the ORCID system, where now authors in all the sciences are encouraged to register their name in an ORCID system, which authenticates them as actual scholars and not as phony storefront scholars. So that's one way to fight this particular malfeasance. But there's no substitute for vigilance. And credible journals know and rely on scholars on whom they've come to rely for routine inspection of papers, and so there's no substitute for that.
Okay, thank you. So, Professor Zelmanov, in the mathematical field, the mathematical industry, you will say, are there the similar, in terms of are there gatekeepers, or is there a similar round of vigilance when it comes to this?
Well, it seems that we live in an ivory tower where everything is different. In all mathematical journals, professional editors have no role at all. All decisions are taken by mathematicians who send papers for refereeing to people whom they know, not some addresses. The problem is different. Mathematician formulates a theorem and writes a proof. These proofs became so complicated, of 500 pages. How can you find a referee who will go through it? It will take him several years, and he is not paid for it. Who would sacrifice several years of his life to do it? So, with many papers, with many proofs, they have been around for a few years. Maybe this theorem was proved, maybe not. Who knows? And even though I mentioned unsubstantiated claims, I want to repeat once again, I would not call it fake science. Everybody makes mistakes. Great people made mistakes. I want to mention in this era of internet, everything is amplified. All claims are amplified. And that is particularly important in politically charged scientific questions, such as genetically modified food, climate changes. Everybody has opinions, but I would like to listen to opinions of those who really understand the question. Also, I regret to say that, at least in the climate science, there was some fake claims, and these people made a lot of damage to credibility of the movement.
How about you, Sir Fraser? Is there any experience that you personally have with regards to this?
Yeah, well, I'm going to speak in a very personal way. In the wake of my Nobel Prize about 15 months ago, I was approached by my university and then by some of my students and said, "You've got to get onto Twitter, Fraser." And my first response was, I was frightened. I didn't want to go there. But I was given this book at Christmas time 2 years ago, Twitter for Dummies. And so I started on a course that I keep very, very high standards. I probably put out, with the help of my liaison officer, 30, 40, 50 tweets from this meeting. And I see my role in many ways as going into a medium where it is probably rife with fake news and trying to set a standard. And so the 280 characters that Twitter allow us to use now, I think back to my days as a schoolboy in Edinburgh where we had to, as part of the examination system, read a piece of prose and then distill it down to a certain number of words. And this was called the précis. And I enjoyed doing that as a schoolboy, and obviously enjoyed it enough to pass my examinations to go to university. So now I'm back with the same art form of using every one of these 280 characters with very good use of prose, for the most part, keeping the grammar absolutely as tight as I possibly can, which is a rare, rare feat when you read a tweet. They're usually, I would say, 80, 90% of them, to me, unintelligible because they are so, just chaotic. So I'm trying to use my prowess as a scientist and my love of the English language, and the last thing it's done is taken me back to the hobby I had as a teenager and then gave up for 40 years of photography. So now I actually do, using an iPhone, take pictures all the time because a picture's worth 1,000 words. And so if you put 4 pictures, if you take that allowed maximum with Twitter, you've got 4,000 extra words. And I'm trying to reach out not only to the scientific community, because then we're just in a sort of echo chamber, but to the wider society. And I have to say, I'm getting an immense amount of enjoyment out of it.
Thank you so much for the sharing. And I guess on that topic of even social media, this is my chance to also tell people about, to remind you that the National Library Board, yes, as mentioned by the MC earlier, we have a campaign called S.U.R.E. Check that out. Go to our website. All right, that's my part of the advertisement. So the third question will be, we are building on this particular discussion already about the phenomenon of fake science, etc. So in your knowledge, in your particular fields of study, are there particular consequences that these perpetrators may face? We talk about them not knowing that their papers may be sensationalized, it may be published, but are there any real hard consequences currently existing, or do you feel should be employed so that in essence the mathematics and the scientific community the integrity of the academic rigor is maintained? So we're talking about measures, consequences. Do you think the current measures are enough, or do you think more can be done? Anyone? Yeah, Sir Fraser?
Well, I come in again. I'm a chemist, and chemistry is not a black and white science. It's full of grayness. And this opens up the opportunity for other types of activity to start, which I want to raise. I'll raise it around a scientist that published a few years ago on things called striped nanoparticles. And this led, his name was Francesco Stellacci. He was at MIT when he started his publications, and has henceforth moved to Switzerland to, I think, EFNL. And he came under a huge amount of attack from two physicists in the UK, one of them Levy in Liverpool and